Hello, this is Dr. Panigrahi. Welcome to my biology classes for medical entrance examination. In this video, I have a talk about the red blood corpuscle. So these red blood corpuscles, in short, known as RBC. These are red in color because of the presence of hemoglobin. Hemoglobin is the iron containing respiratory pigment. That's why blood is red in color. And these are known as corpuscles. This is the synonym of particles or bodies. So these formed elements lack of some of the typical features of the cells. That's why these are known as the particles or the bodies present in blood, and that's why these are known as the red blood corpuscles. Such red blood corpuscles, the half of the volume of blood is RBC, and such red blood corpuscles actually estimated by the hematocrit value. This is also known as the packed volume of RBC. It is estimated that 1000 number of RBC present for 1 WBC, and such packed volume of RBC, also known as volume percentage. If the volume percentage below and high of the normal hematocrit value, then this means the increase or the decrease of the count of the RBC. The normal value of hematocrit in male, which is 47 plus or minus 5%. In case of female human, the normal value of hematocrit 42 plus or minus 5%. This is the normal value. If the value increase or decrease, it indicates that the number of RBC may increase or decrease. And such hematocrit value, it is important, and which is actually estimated by the instrument which is known as the Winthrop tube. So such hematocrit value which is estimated by the Winthrop tube. Almost all vertebrates having the red blood corpuscles, but there are some known vertebrates live in the Antarctic region. They are without RBC. So one is the crocodile, ice fish, and another maybe the larvae of eels. These are also without RBC. They are live in the oxygenated ice water in the Antarctic region. So these are the known vertebrates lack of RBC. These are red in color because of the presence of the iron containing pigment. Now come to the structure of red blood corpuscles. So the vertebrate RBC are nucleated. the vertebrate RBC are nucleated. So, except mammals. So, suppose that the nucleated RBC present in all vertebrates except mammals. And in mammal, there are the non-nucleated RBC. So, nucleated RBC present in all vertebrates except mammals. So, that is the exception. And non-nucleated RBC present in mammals except camel and llamas. So camel and llamas, they have the nucleated RBC. Those having the nucleus, the RBC is oval in shape, having the centrally placed nucleus. So these are here oval in structure and disc shaped. These are nucleated, that's why this is biconvex. But in case of mammals, and particularly in human, RBC are known as non-nucleated, or you may say these are enucleated or X-nucleated. Enucleated and X-nucleated means in immature condition RBC possessed nucleus, but in mature condition RBC lose nucleus as well as some of the organelles like Golgi body, mitochondria, endoplasmic reticulum, centrosome. So the losing of such organelles as well as nucleus, this is the advanced evolutionary features. That's why the RBC accumulate more and more hemoglobin molecule on the surface. So losing of such nucleus and the organelles, the RBC here, it is biconcave. So if you take the picture, then this is the biconcave. So here the RBC are biconcave. These are circular in structure or the shape. These are the circular in outline, disc shaped. The diameter of human RBC about 7 to 8 micron, and at the edge region it is more thick, so thickness about 2 micron, and at the center the thickness is about 1 micron. So this is the structure of human RBC. So because of presence of nucleus in case of frogs RBC, these are oval in shape, disc shaped, biconvex, and they are also flattened. So nucleus also present in llamas and camels. So these structure also oval, disc shaped, biconvex and flattened. So the losing of such nucleus, it becomes biconcave. That's why number of RBC may adhere to each other and which forms the stalks of the coins like a coin or piles up like a coin, and which is known as the Rolex. So Rolex, it is the another important features of the RBC adhere to each other and which forms the Rolex. The membrane of RBC, which is more flexible, and the membrane of RBC is known as Donald's membrane. It is more flexible, that's why it easily passes through the capillaries, and the internal skeleton of RBC is made up of another protein known as the stromatin protein, which also contains some of the cholesterol also. So the internal skeleton of RBC made up of stromatin protein. Membrane is more flexible. It is red in color because of the presence of hemoglobin on the surface. So about 1 RBC holds or poses 26.5 crore of molecules of RBC. What about the lifespan? The lifespan of mammalian RBC 120 days, but in case of frog the lifespan is 100 days. Now come to the number of RBC. How many number of RBC actually present per the unit volume of blood? So in case of human, half of the volumes of blood actually the RBC. So in human male, the number of RBC is 5 to 5.5 millions per 1 deciliter of blood, or you may say 1 cubic millimeter of blood. In case of female, the amount is 4.5 to 5 millions per 1 deciliter of blood. If the number increased from the normal level condition, and this is known as the polycythemia. If the number of RBC increased from the normal level, this is known as the polycythemia. If the number decreasing from the normal level, this condition is known as the erythrocytopenia. So erythrocytopenia means the decreasing of RBC count from the normal level, and polycythemia condition, it is observed those live in hilly region or high altitude region, they have the more number of RBC per volume, unit volume of blood, and the condition is the polycythemia, and which causes of the rosy cheeks. And the erythrocytopenia means the decreasing of RBC from the normal level of the blood. Now come to the formation of RBC. Actually, the formation take place in different organ in different stage of the life. Actually, the formation of RBC is known as erythropoiesis. This is the formation of RBC or the hemopoiesis, also you may say hemopoiesis. The organ from where erythropoiesis taking place, the organ is known as the erythropoietic organs. The erythropoietic organs in fetal condition and the fetal condition, these are several types or several in number. Like in fetal condition, erythropoiesis takes place in kidney, in liver, in yolk sac, in spleen or bone marrow. But in after birth, the hemopoiesis taking place only in red bone marrow. The red bone marrow cell which germinate into RBC, these red bone marrow cell actually known as hemocyaноblast. So hemocyaноblast, these are the red bone marrow cells. Such red bone marrow cells forms the rubriblast cell. Rubriblast cells, or it also known as the myoblast. Myoblast cell. Such myoblast cell again which forms the reticulocyte cell. Reticulocyte cell. Such reticulocyte cell eventually forms the red blood corpuscles. So mature red blood corpuscles devoid of different organelles and nucleus, but reticulocyte cell which contains nucleus and different organelles. So up to this, these precursor cell of RBC contains different organelles as well as the nucleus. Now come to the hemoglobin. So hemoglobin, this is the respiratory pigment which transport the oxygen. So oxygen covalently bind with the hemoglobin. So hemoglobin in short Hb. So one molecule of hemoglobin can bind with the 4 molecules of oxygen, and which forms oxyhemoglobin. Oxyhemoglobin. Oxyhemoglobin containing RBC present, which is known as the oxygenated blood. Oxygenated blood. And without oxygen, the RBC or the blood is known as the deoxygenated blood. The oxygenated blood actually bright red in colors, and without oxygen the blood is deoxygenated blood, which is dark red in colors, dark red or somehow blue or somehow purple in color. So one hemoglobin molecule, this is the respiratory pigment, iron containing respiratory pigment, which has two components. One is the protein, the protein component, which is known as globin or globulin, and the non-protein part or iron containing part, this is known as the heme or this is heme. So here 4 molecules of heme and 1 molecule of globins are present in single molecule of hemoglobin. So 4 heme molecule bind with 1 globin molecule, which forms a single hemoglobin, and the globin, which is composed of 4 peptide chain, and these polypeptide chains are alpha, beta, gamma and delta. So alpha polypeptide chain composed of 141 amino acid, and each beta, gamma and delta, each one composed 146 amino acid. This heme group or the heme component, which contains the which is the derivative of the porphyrin derivative, and the structure is very much similar with the chlorophyll found in the leaf, but in case of heme there is the ions in place of magnesium in chlorophyll. In chlorophyll the centrally magnesium ion present, but here ion present in place of magnesium, but the total ring structure is same. So this is the porphyrin derivative, and this is the composition of hemoglobin. Because of presence of such ion, which forms the red in color, and the hemoglobin content in case of human male, the hemoglobin content is 15 to 60 gram per 100 ml of blood, but in case of female it is slightly low, 13 to 14 gram per 100 ml of blood. If the hemoglobin content low from the normal level, then the condition is known as the anemia. This is the anemic condition, and this is known as the anemia, where there is the very low amount of hemoglobin present. The vitamin B12 helps for the formation of hemoglobin, and the vitamin B12 is known as the cyanocobalamin. So deficiency of vitamin B12 or deficiency of the hemoglobin, you may say this is the anemic condition. Now come to the hemolysis. Hemolysis, the removal of RBC is known as the hemolysis, or the breakdown of RBC is known as the hemolysis or hemolysis. Hemolysis or lysis, the breakdown of RBC or removal of hemoglobin. So after removing of hemoglobin, the empty RBC cell is known as the ghost cell, and this is also known as the shadow of RBC or shadow of RBC. After 120 days or after the death of RBC, the dead RBC are brought to the spleen. So breakdown of RBC taking place in spleen. That's why, or the dead RBC are brought to the spleen. That's why spleen is known as the graveyard of RBC. And some of the RBC also stored in spleen. That's why spleen also known as the blood bank of body. If you put the RBC in the 0.5% salt solution, then RBC absorb water and which swells and burst. After bursting of RBC, left the ghost cell or shadow of RBC. That's why this solution is known as the hypotonic solution. If we put the RBC in 0.8% salt solution, then RBC lose water and which becomes shrink, and which also known as crenated, and the solution is known as hypertonic. This solution is known as hypertonic solution. If you put the RBC in 0.7% salt solution, then RBC remain unaffected. So such solution is known as the isotonic solution. The breakdown of hemoglobin, which forms two pigment, bilirubin and biliverdin. So the presence of more bilirubin pigment in blood which causes jaundice, both are the yellow pigments.